Let's take a review of scientific notation of scientific measurements. We use this to express extremely small or extremely large numbers. We often use this in scientific calculations. It makes things just a lot easier. We need to be precise and accurate, and this is amazingly helpful. Scientific notation is a way of writing a number as a multiplication problem, where the first number is greater than 1, and then you multiply it by a number that is a power of 10. So you've got something between 1 and 10 to start it, and then it's multiplied by a power of 10, 10 to the 1, 10 to the 2, 10 to the minus 5, and so forth. So here's our powers of 10. And these aren't all of them, obviously. In exponential form, for instance, the 1 million is 10 to the 6th. A lot faster to write and extremely accurate, and you don't have to count zeros. And then when you get to 10 to the minus 3, you see it's got a decimal point with 2 zeros in it. That just makes it a lot easier because you don't have to count zeros. So to change from standard form to scientific notation, you place a decimal point in the number, write both numbers down, write the standard notation first, and then you put the decimal point in such a way that there is just one non-zero digit to the left of the decimal point. Then you count the number of places that the decimal point has moved from the original number to get to the number you want to express, the number between 1 and 10. And that is the exponent on the 10, either positive or negative. If the number originally was less than 1, it's got to continue being less than 1, so you multiply by a power of 10 that brings that down to less than 1. That's a negative exponent. If the original number is greater than 1, then the exponent on the 10 has to be positive. For example, you see 4,750,000, and you noticed that I counted the original decimal points right at the right end of the number, and I moved it 1, 2, 3, 4, 5, 6 places to the left to get 4.75. So if you moved it 6 decimal places to the left, the answer must be 4.75 times 10 to the 6th. And the original number was greater than 1, so the exponent on this scientific notation number has to be a positive number. 10 to the 6th is a million. So you've got 4.75 millions. That's another way to say it in English. Here's another example. 0.000789. We used 7.89 as the first number, and we moved it 4 decimal places to the right to get from the 0.000789 to 7.89. That number, you look at it and you say, oh, those zeros after the decimal point are headaches. Well, it's a number less than 1, so the exponent is negative, and remember, if there's zeros to the right of the decimal point, before you get to the number you're really looking for, the exponent is negative. So here's one to try. And if you need time, you can just turn the video off and check the work. There's 6.15 times 10 to the 4th. There's another one. That's 8.496 times 10 to the 7th. You notice those trailing zeros don't show up. That becomes important. And 321, that's 3.21 times 10 to the 2. 10 squared is 100, of course. Try some more. Oh, look at those zeros after the decimal point. Isn't that a headache? 5.27 times 10 to the negative 4th. You had to move the decimal point 4 places to the right. Oh man, you count those zeros. Oh, you're moving it to get to the 4, you're moving it 7 places to the right. Remember, the first number has to be a number between 1 and 10, so that number can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Never 0. So to change from scientific notation to standard form, I don't know why you do that, but sometimes you might have to. Now you're going to move the decimal point to the right if the exponent is positive. Well, that makes sense, because 10 to the third, say, is 1,000. So you got the 3 zeros at the end. And if you've got a negative exponent, you're going to move the decimal point to the left, and you'll be left with some zeros after the decimal point. And those are pains, aren't they? So 5.024 times 10 to the third, we move the decimal point from right after the 5 to right after the 4. You've moved 3 places to the right, 10 to the third. 1.015 times 10 to the negative 8. Well, you need the 1015 on the right end. And to get that from 1.0 to all the way over here, you have to move it 1, 2, 3, 4, 5, 6, 7, 8. 8 places to the left. And you're left with a number, mercy. You don't want to have to do that. Maybe it's necessary sometimes, but I'll tell you, it'll never be necessary in my classes. So, try these. And one nice thing about scientific notation is that you can count significant digits very easily, because you count the digits that are in that first number. Anything that appears in there are significant digits. So 9.340 times 10 to the third, 4 significant digits. That might have been written in standard notation as 9340, but in that way, the 0, you don't know whether it's significant or not, but if you write it like this, you know that it was 9340 with a decimal point right. It was 9340, period, and the uncertain digit was the 0 at the end. So, that's how to do scientific notation in 8 minutes.